What do you think growth looks like? Is it the summit or the climb? Is it leisure or toil? Is it the comfortable routine or the painful changes? Growth is the work, the changes, and dealing with the discomfort. That is what the Ethereum ecosystem is going through. A reorientation paving the way to growth, which Ethereum 2.0 is expected to bring. In this piece, we are going to talk about the operating economics of DeFi and how it is likely to be impacted by the London hard fork, which went live on 5th August 2021, that is, just last week. A case in point is that more than 80% of DeFi locked value is in Ethereum based systems. So changes in Ethereum fee structure are likely to influence the DeFi ecosystem drastically. But first, let us understand the DeFi operating economics. The popularity of decentralized finance was accompanied by the drastic increase in the gas prices, the primary driver of DeFi operating economics. The DeFi ecosystem gained momentum in 2020. The gas prices experienced drastic inflation at the same time due to the increased demand on the Ethereum blockchain. The gas prices increased from the monthly average of 13 GUI in April 2020 to 193 GUI by September 2020. The gas prices are still considerably high even in the first week of August 2021. These high gas prices were also accompanied by a drastic increase in volatility, increasing the unpredictability in the DeFi operating economics. Let us first understand the cost structure in the Ethereum blockchain, and then we'll talk about the London hard fork. The fundamental building block for cost structure in Ethereum is gas. Gas refers to the unit that measures the amount of computational effort required to execute specific operations on the Ethereum blockchain. So if transactions or operations require higher computational effort, more gas is required. Smart contracts, which are used in DeFi systems for the execution of transactions, are sets of operations. To understand how Ethereum cost structure worked before the London hard fork, let us compare running a smart contract on Ethereum with a car rental service. Say you are planning a trip which involves various stops. You have to go to the mall, stop at your friend's place, then visit your aunt, etc. etc. The car rental company charges as per miles driven in a trip. The cost per mile changes in real time based on the demand for cars. When demand is higher, cost per mile is higher, and when the demand is lower, cost per mile is lower. So total cost for a trip equals to number of miles multiplied by cost per mile. If we compare this with running a smart contract on the Ethereum blockchain, the amount of gas required to run the smart contract can be compared with the number of miles, and the gas price can be compared with the cost per mile. So the cost involved for the execution of a smart contract equals to total gas required by the smart contract multiplied by current gas price. In Ethereum, the gas price is quoted in GUI, which is a subunit of Ether. 1 Ether equals to 1 billion GUI, that is 1 GUI equals to 10 to the power minus 9 Ether. Now let's take one example. Say we are transferring 1 Ether. It costs 21,000 gas units to transfer 1 Ether on the Ethereum blockchain. If the gas price is 54 GUI currently, the transaction will cost 1,134,000 GUI, which equals to 0.001134 Ether. Now, coming back to the car trip example, consider that you are not sure about how many miles the whole trip will take because you are visiting your friend for the first time and not sure about the exact location of her house. But the car rental company insists on mentioning an estimated maximum number of miles for your trip and asks for an advance based on the maximum estimated number of miles. In the case of Ethereum smart contracts, the gas limit is a similar concept. The gas limit signifies the maximum amount of gas the user is willing to spend for the smart contract. If the actual gas required by the smart contract is lower than the gas limit, the remaining gas is returned back to the user. But if the actual gas required for the smart contract is higher than the gas limit, the transaction fails with an out of gas error. The gas limit will be completely burned and the user will not get it back. Now coming to the cost per mile or gas price in the case of Ethereum blockchain. As mentioned in the case of car rental, the cost per mile changes in real time based on demand for cars. Similarly, in the case of Ethereum smart contracts, prior to the London fork, the gas price changed based on demand on the Ethereum blockchain. The cost also varied based on how quickly the users wanted their smart contracts executed. This is because prior to the London fork, the gas price was based on an auction process and users willing to pay higher gas prices were given priority in transactions. To make the concepts clear, let us dig a little bit deeper. Why exactly do we need gas in Ethereum? Well, the primary reason is to reflect that computational power is a scarce resource. So who provides these computational resources in Ethereum? Miners. Mining is the process of creating a block of transactions to be added to the Ethereum blockchain. So, the miners decide which transaction to be added to the blockchain through a bidding process. Miners add transactions in blocks based on the compensation they receive. Before the London fork, the whole fee paid for smart contract execution used to be transferred to the miners. Now, scarcity for computational power was created by setting a commitment interval of around 15 seconds between blocks and a maximum gas limit per block. The rise of DeFi resulted in dramatically high and highly volatile gas prices. Ethereum is not the only blockchain for DeFi. High costs in the Ethereum blockchain may motivate users to give preference to other networks such as Solana or Cardano. But the bigger issues were unpredictability and lack of transparency. The highly volatile gas prices resulted in the unpredictability of transaction fees. Remember that the fee is calculated in Ether, and the volatility in the Ether prices compounds the transaction fee uncertainty in terms of fiat currencies. The lack of transparency came from the inefficiencies in the auction process. For users, setting appropriate gas prices was a challenge. Unless users bid significantly higher gas prices than the prevailing gas price, they could not be sure that their transaction would go through. At the same time, if a user bid an excessively high gas price, the transaction would be processed at the excessively high price and the user would end up overpaying for the transaction. If we compare this with the car rental example, this system would be similar to the customers only getting to know exactly how much to pay per mile after the completion of the trip. Not only that, the customers would have to bid how much they would be willing to pay per mile, and the customers willing to pay the highest would get priority in getting a car, and the lower bidders would need to wait. It is quite likely that many customers would end up paying a higher price than required, and many would change the rental service provider. Another problem was that the auction process resulted in a perverse incentive. The miners could artificially increase the gas prices by including their own transactions in the block, thus creating artificial demand. Now we know the issues. So how exactly does the London hard fork or EIP-1559 plans to solve these issues? The London hard fork is technically called EIP-1559. EIP stands for Ethereum Improvement Proposal. Anyways, what does this EIP-1559 intends to change in Ethereum blockchain? The official title of EIP-1559 is Fee Market Change for ETH 1.0 chain. That is, it intends to change how the gas fee is calculated in the Ethereum blockchain. It replaces the simple auction-based mechanism for gas pricing with a transaction pricing mechanism that includes fixed per block network fee that is burned and dynamically expands or contracts block sizes to deal with transient congestion. The key points here are that the London fork ends the auction model for gas pricing and introduces a base fee plus priority fee based model. It introduces variable size blocks with a target and a maximum block size, and the base fee is adjusted proportionally to how far the current block size is from the target size. So let us discuss these points one by one. First, the London fork ends the auction model for gas pricing and introduces a base fee plus priority fee based model. The base fee is set at the block level and adjusted up and down based on how congested the network is. Here is the interesting part. the whole base fee will be burnt. That is, the miners will not receive any part of the base fee. As the base fee is tied to the demand in the Ethereum blockchain, burning the base fee will remove the perverse incentive for miners to increase the network activity to jack up gas prices. So how would the miners get paid? Although miners earn through block subsidy, transaction fees were a significant income source for miners. EIP-1559, that is the London fork, introduces priority fee, which is similar to tipping. The miners will only receive the priority fee, so the miners will prioritize transactions based on the priority fee. The second point is that EIP-1559 introduced variable size blocks to Ethereum. Each block has a target size of 15 million gas and the maximum size of 30 million gas. The target block size is the equilibrium size. If the demand is higher than the target size of 15 million gas, the base price will be increased for the following block. And if the demand is lower than 15 million gas, that is the target size, the base price will be decreased in the following block. The London hard fork effectively replaces the gas price volatility with block size volatility. That is, the block size acts as a shock absorber for gas price. The third point is that the base fee is adjusted proportionally to how far the current block size is from the target block size. As per EIP-1559, the base fee can increase by a maximum of 12.5% per block. This exponential growth makes it economically non-viable for block size to remain high indefinitely. Making predictions of gas prices is now more reliable as the maximum increase in the base price is capped from one block to another. Say, for a transaction which to be included at the fifth block from the current block, when the current base fee is 100 GUI, the maximum possible base fee at the fifth block from the current block can be 160.2 GUI. EIP-1559 allows the users to set a maximum gas fee as well. So users can set a maximum base fee as 160.2 GUI and add some priority fee with that. And if the actual fee is lower than the max fee, then the remaining amount is refunded to the user. So how are these changes going to impact the DeFi ecosystem? As EIP-1559 in itself does not increase the scalability of the Ethereum blockchain, it is unlikely to solve the issues of high fees, but it is likely to improve the wait time and remove fee market uncertainties, removing the spikes in the gas prices. So what are the implications for the DeFi ecosystem? For that, let us understand the role of Ethereum or any other blockchain in the DeFi ecosystem. They are infrastructure providers. The blockchains for DeFi applications are similar to data networks for streaming services or online gaming. Now consider a situation where the data cost per kilobyte changes continuously in real time based on demand for data, and those changes can be anything 10x or 100x. Would streaming services or online gaming ever become popular in that situation? Probably not. Stability in the infrastructure cost and speed are prerequisites for the growth of many industries. By reducing wait time, removing cost uncertainties from the Ethereum blockchain, and creating a surge handling mechanism with flexible block sizes, EIP-1559 is likely to make the Ethereum blockchain attractive as an infrastructure service, and in turn encourage further growth in the DeFi ecosystem. Further, introducing the concept of priority fee, EIP-1559 is aligning the incentives of the DeFi users and the cost structure in the Ethereum blockchain. All DeFi applications do not require the same speed of transaction. Applications such as decentralized exchange trading may require much faster transactions than, say, lending interest payments. DeFi developers now can define the cost structure for their applications based on the required transaction speed. Growth is the work, the changes, and dealing with the discomfort. And it is likely that the DeFi ecosystem will need to go through some discomfort because of the London hard fork, design changes, outages, and changes in algorithms. But we need to remember that EIP-1559 is paving the way for Ethereum 2.0. Ethereum 2.0 is bringing proof of stake, sharding, etc. to make Ethereum blockchain more scalable and sustainable. The London hard fork is activating some of the changes required in the ecosystem. With this is Sam Ghosh. Bye-bye.